Okay. Then what question do you have? Do you have questions? Do you want to some specific type of problems? Do you
Yes, we do. Maybe to solve some problems with conics, like we did Monday.
want to solve a problem with conic? Other suggestions?
If they are not a specific question, I can provide some examples with conics. Okay, I have multiple exercises. Let's say we have 4xy
Oh, we have first one.
minus 3y squared plus 4x minus 40y, 14y minus 7 equals 0.
Okay, this is not something which we have seen at the seminar, right? Yes.
Okay.
I was looking at the. Can you repeat, please?
So it's not good.
Okay, let's see what happens here. So, I'm going to remind you the steps.
I took the problem from a book. Is good, so. Oh, okay.
See what we get. Maybe we get the generate conic. I don't know. Let's see. Step one consists of writing the matrix associated with this quadratic form. Okay, so we have to write the matrix A, which is the matrix associated to the quadratic form. I'm going to write in this way. Fine. Okay. Step five. A.
Okay, 0.
So we have just for x This is just for x, right? Not for x squared.
Yes.
Okay,
Yes.
so it's just for x without it. Minus. Okay, so it is 0 here because we don't have x squared. Okay, so just this one is the quadratic form. If you had an x squared, then x squared will be considered in this quadratic form. Then you have,
2.
yes,
Then again 2.
yes, and
Uh,
minus,
3.
yes, because this one must be divided by 2. Okay, then we have to find the eigenvalues. Let's see how the eigenvalues look like. We have that of A minus lambda times I2 equals 0. So minus lambda 2 minus 3 lambda is, so we have lambda times 3 plus lambda because we have minus here and here. Minus 4 is 0. Okay, so lambda squared plus 3 lambda minus 4 equals 0. And we have that lambda 1 is, lambda 1 is 1, okay, because if you place lambda by 1, you get 0 here. And lambda 2 is
Minus 4.
minus 4, yes. The product is minus 4. The sum is minus this one, which is minus 3. So these are the eigenvalues. Okay, let's go to step 2. We find eigenvector and for lambda 1 equals 1, we have to solve A minus lambda 1 I2 times V equals 0, 0. Okay, we have to subtract lambda on the main diagonal. So we have minus 1, 2, 2, and minus 4. V is AB. And we get minus A plus 2B is 0. And 2A minus 4B is 0. So A is 2B. So V is 2B and B, which is B times 2, 1. And we denote by V1 this vector, 2, 1. Okay, I'll give you 2 minutes to find the eigenvector for lambda 2. Have you found the eigenvectors?
Yes.
1 minus
Yes.
2.
1 minus 2 should be. Let's see. Two of 4, 2, 7. Oh, not 7 because 3, 1. Okay, 2, 1. Times AB is 0, 0. So V2 is this one. Are they diagonal vectors?
Yes. If you check the dot product, it's 0.
Exactly. You can check the dot product, or if you want, you can take a look at the values of lambda and lambda 2, and you know that if lambda 1 is different from lambda 2, then it means that V1 and V2 are orthogonal vectors. And now we have to find their norms. So norm of V1 is square root of 5. Norm of 2 is square root of 5. So we have two vectors, 1 and 2, which have the norm 1. And that 1 is 1 over square root of 5 times 2, 1. Okay. And W2 is 1 over square root of 5 times 1 minus 2. And we have to go to step 3, where we have to do a rotation. Actually, from the beginning, you should notice if there's to a rotation or not. When you look at this form, if you see that there's a term with x, y, it means that you have a rotation. Okay, so if you have this term with x and y, means that you have to do a rotation. So you have to write step 1, step 2, step 3, and step 4. Because step 1 and step 2 help you to find the rotation in step 3. So if you need a rotation in this term appears, it means that you have to find the step which were mentioned. But if you don't have this xy term, means that you will go directly to step 5, which means the translation. Okay, so if xy doesn't appear in the equation, we to 5, which means translation. Okay, so in this case, we have to do a rotation, so we have to use matrix, which consists of W1 and W2, and you have two options. Either you start with W1 or you start with W2. You have to check the determinant in each case and to choose the matrix which has determinant equal to 1. Okay, so I'm going to write this fact. here, the rotation, you have two choices. The first one is to write this matrix, which consists of W1 and W2, where the canonical basis of R2 and B prime is the basis consists of W1 and W2, or you write this matrix with 2 and W. But the idea is to choose the matrix with determinant equal to 1. We choose CBB prime such that the determinant of CB B prime is 1. It's also correct if you choose the matrix with determinant minus 1. But in this case, you have a rotation and reflection. So it means that in the end, you have to switch x and y. So if we choose CB B prime such that the determinant of CB B prime is minus 1, we have rotation and okay, and having this reflection means that in the end you have to switch x double prime with y double prime. So you have to switch x and y. And because there is the risk to forget about switching these variables in the end, I recommend to work with matrices with determinant equal to 1. Okay, but it's not a mistake if you work with determinant minus 1, but don't forget in the end to switch in the final equation x double prime with y double prime. Okay, let's see, how to write vectors W1, W2 such that you have a matrix with determinant equal to 1.
We can choose the other version with W2 and then W1. This is with determinant 1.
X. Let's see. So if we choose the matrix W1 and W2, we'll have 2 over square root of 5, 1 over square root of 5, and 1 and minus 2. Okay, so in this case, the determinant is minus 1. So I suggest to choose this matrix. So we choose this matrix, which contains W2 and W1. This is 2. Okay, so we take first W2 and then W1. And if you compute the determinant will be 1. So we choose this matrix. Okay, and the notation that we have has the form xy equals cb b prime times x prime y prime. So in our case, xy is this is x prime plus 2 over square root of 1, and y is minus 2x prime plus y prime over square root of 5. At step 4, we have to use the rotation to change the equation of g. So we replace x and y by the above expressions. In the initial equation. So let's see. The initial equation was this one. And let's make the computations. We have 4 times this product. Minus 3 times this one squared. Plus 4 over square root of 5 times this one. Minus 14 over square root of 5 times this one. Okay. Minus 7 equals 0. Okay, and I will give you 2-3 minutes to make the computations here and to see the form that you get in the end after adding the terms with x prime squared and so on. Okay, so make a few computations here. Have you made the computations?
Not all of them, but
Some of them to see if your computations until correct, and then you continue. So you have something over 5. And you get from here minus 2x prime squared with a 4 is minus 8x prime squared. And from here you have actually 4x prime squared times minus 3 is minus 12. Okay, so you have minus 8 from here and minus from here. So you have minus 20x prime squared, correct?
yes.
20x prime squared. Having potential, you won't obtain yet the term with x prime, y prime. Okay, so this term must disappear, and let's check if we won't have this term. So we have x prime, y prime, which has the coefficient 1, minus 4 is minus 3, and minus 3 times 4 is minus 12. Okay, so we have minus 4 again, plus 1 minus 3 times 4 is minus 12. Here we have 4 with a minus in front of it, times minus 3 is plus 12, okay? So we won't have this term. And now let's move to y prime squared. From here, we have 2y prime squared times 4, which is 8y prime squared. And from here, we have minus 3. Okay, so 8 minus 3 means 5y prime squared. Let's take a look here. We have 4 over 5x prime with plus 8 over square root of 5x prime. So we have in the end 32 over square root of 5x prime. That's because we have 28 plus 4 is 32. And here we have 8, and minus 14. 8 and minus 14 means minus 6. So we have minus 6 over square root of 5 y prime. And then we have a minus 7 in the end. Minus 7 equals 0. Let's check. We have minus 4x prime squared plus y prime squared plus 32 over square root of 5x prime minus 6 over square root of 5y prime. Minus 7 equals 0. Can you tell me what type of conic will end?
A hyperbola.
Exactly. Because we don't have xy term, we can tell exactly that we have a hyperbola, since there is a coefficient which has a minus, and here is something with plus. So if you have a difference of squares, it means that you have a hyperbola. And now, what we should do?
We have to form squares.
Exactly. Have to form squares, which equals to write first the terms which contain x prime. So we have minus 4 times x prime squared plus 32 over this one plus this one minus 7 equals 0. And now pay attention to the following fact. If you have a coefficient which is not 1, you have to force a factor. So you have to write that coefficient in the front of a bracket because you need to make here a translation in the end. And the translation has the form x prime plus alpha equals x double prime and y prime plus beta equals y double prime. Okay, so this is a translation. In a translation, we cannot have a coefficient times x prime. So here you must have 1, okay, always 1. And this is why I'm writing this coefficient in front of this bracket. So I have x prime squared minus 8 over square root of 5x prime. Okay, writing it this way. But here, I have coefficient 1 is perfect. So I have to complete 2 squared. 1 squared minus, I'm writing 2 here from the formula times prime. So I write here.
3 over square root of 5.
3 over square root of 5. I have to add this square, then I have to subtract. Okay, so you have 1 squared times, and here you get x prime squared minus 2 times x prime times, and I need here 4 over square root of 5. Sorry. Okay. Mulțumesc. And then I have to add this one squared, which is 4 over square root of 5 squared. And in the end, I have to subtract this term, but I'm going to write in this way. I'm putting actually a plus because when I subtract this, I have a minus in front of it, so I get a plus. Plus 4 times 4 over square root of 5 squared. Okay, then I'm going to take these terms and to write them in square root of square root of 5 squared. Okay, like that. Then it's not 5 and get 4 times x prime minus this one plus this one. And now see, we have 16 times 4, which is 64, minus 9 means minus 55. Okay, over 5 from here and here, minus 7 equals 0.
Isn't it plus 55 over 5?
Yes, I was looking at minus, I don't know which minus. Here, you have plus. That's oh, so what we should do now? Now we should do
Translation.
a translation, exactly. We should denote this one by x double prime and by y prime. So this was denoted as step 5. Okay, so we have step 5. Translation. Okay. So this is translation. And in the end, get x prime squared plus y double prime squared. And we have here 11 minus 7, so is 4. But I'm going to write in this way, minus 4. Then what we should do?
We can divide by -4.
Exactly. You've told me earlier that we have a hyperbola, and having a hyperbola force you to divide by -4 here to obtain a 1 in the right side. So we get x double prime squared minus this 1 over 4 equals 1. Okay, so that the equation of hyperbola here over 1 because you have over a squared, so a is 1 and b is 2. And this is a hyperbola. And that's all.
And I have a question for this problem. Has one point that said to find the center of the hyperbola. How we can make this?
If you want to find the center, you must solve the following system. But we won't uh, discuss the solution because you won't see something like this in the final exam. Okay,
Oh,
but
okay.
just the idea. I'm pointing the idea. If we denote this function by g, so finding the center means solving the system which has the equation the partial derivative of g with respect to x equals 0 and the partial derivative of g with respect to y equals 0. Okay, so if you want the center, you have to compute the partial derivative of this function with respect to x and to solve the equation that derivative equals 0 and the same for y. And the solution of that system is the center.
Oh, okay. Thank you.
Welcome. What other questions do you have here?
In this exercise or another question?
In this exercise, if we have, if not, other questions.
I had a question about another exercise, if we can do it.
Okay, but are there any other questions about this problem?
I think it's clear.
Please tell me. Mohammed. Mohammed, I'm listening. What questions do you have?
I'm gonna dictate. Let u, v, and w be free vectors.
In plain space.
It just says free vectors.
Okay.
So that the length of u is 1. And the length of v is 2. And the length of w is 3. The length, the angle formed by u with v has pi over 6. And the angle formed by u with w is pi over 3. Compute the length of u minus 3v plus 2w.
So we have three vectors, u, v, and w. We suppose that they have the same origin, otherwise we cannot make this sum. So let's say that u is this one, and the length is 1. No, let's draw a shorter vector. Okay, this is u. V has the length 2, and the angle between u and v is pi over 6. Pi over 6 means 30 degrees. So let's say that this one, and v has 2, so it's not the length of u. Okay, this is 30 degrees, pi over 6. And this is v. And w is a vector of length 3. And you know that the angle between u and w is pi over 3, so it's 60 degrees. And you have here two cases. The case when w is here, so the case when you have this vector w here, and the case when vector w comes here, and you will have 90 degrees. So let's discuss both cases. First, we start with the one in which we obtain a 90 degrees angle. So let me make again this drawing. I think that I'm going to draw V in this way. Okay, so this is V. U is half of the length of V, so this is U. Up top, we have 30 degrees angle. Right, so this is U. And this is W. Okay, because this angle has 60 degrees. And this one has 30 degrees. Okay. Let's see how U minus 3V plus 2W looks like. So we have U minus 3V. Minus 3V means that you have to draw the vector V in this way, because this is V, this is minus 3V. So let's see if I have here enough space. So this is V. Okay. And this is minus 3. Okay, so it's minus 3. And the vector U is this one. And W means and this is minus 3. Okay, let's see. How do we add the vector 2W and minus 3V? How do we add minus 3v and 2w? Well, you know that the sum of two vectors with common origin means the diagonal of a parallelogram which is formed with the edges given by these two vectors. The length of minus 3v is the length of minus 3v is
minus 6.
minus not minus. Okay, it's just because we talk about the length. Okay, this is 2, this is 2, this is 2, this is 6. And the length of 2w is
It's 4 or oh 6.
it's no, because the one has 3.
Okay.
Okay, this is 3. This length is 3. So here you have a square actually. We have a square. And this diagonal is actually a sum. It's a sum. Okay. So this is minus 3 plus 2. Okay, how do you add this vector with this one? Well, we have to form again a parallelogram, but in this case, we form a parallelogram, we'll see that the sum will be this diagonal. Okay, so we know nothing about this, right? So let me draw in this way. We have this diagonal. So this is the sum between these vectors. But you cannot find this sum from this drawing. Actually, if we have a parallelogram, and we have a diagonal given by two vectors, given by the sum of two vectors, let's say that this is not from this is B and this is B. How do we find the length of this diagonal, which is the sum of A plus B? So let's say that this is the vector S, whereby S, I mean the sum of A plus B. How do you find the length of S?
A times B times cosinus of AB.
Well, let's see. Let's make a clip from here. So we have this one and this one. You know that this is A, but this is also A, right? Because they are equal vectors.
Yes.
And this is B, and this is S. This one here is alpha. Alpha is the angle between A and B. But I need this angle because I'm going to work with this one in this triangle. And this angle is pi minus alpha, right?
Yes.
Because this one plus this one is pi. So this angle here is pi minus alpha. And if I want to find the length of S from here, I have to apply the cosine theorem, which tells me that this length squared is the length of A squared plus the length of B squared minus 2 times the length of A times the length of B times the cosine of this angle, which is pi minus alpha. Okay. Where is the angle between A and B. And if you like, you can write that cosine of p minus alpha of pi minus alpha. So this, if this is alpha, then cosine of pi minus alpha is pi minus alpha. And cosine of pi minus alpha is cosine A cosine B sine A sine B, right? And sine of b sine of, so it goes up. You can see this from this picture, because if this is alpha, then cosine is this length, and this angle is pi minus alpha, so cosine is this length, and they have opposite signs. So this is cosine of alpha with a minus in front of it, and in the end you will have plus cosine of alpha. Okay, so let's see what we have. So in our case, let's say that this is A. Okay, let's say that A is minus 3 plus W. And B is one which is Q. And you know that the length of B is the length of U, which is 1. Okay. Find the length of A. How do you find the length of A? Well, you have two methods here. The first method consists of taking a look at this picture and trying to find the angle between 2W and minus 3W and minus 3V. And you know that the angle between them is 90 degrees. So actually the length of this vector is the length of the diagonal of a square. This has the length 6, this is 6, and this will be, the length of this vector will be
6 square root of 2.
actually, this is 6, this is 6, this is 6 square root of 2. Okay. So note that this length is this one. It can decrease the length of this vector here, and you could use this equation to find the length of the spectrum of the length of these sides. But when I have found the length of A, I used this image. And I've told you that there are two cases. The first one in which W looks in this way, and the second one in which W comes here. And in the second case, when W comes here, you won't have a 90 degrees angle. But instead of finding the length in each case by following the image, I'm going to use the same formula for the first case and the second case to find the length of this vector. So let me apply for the first case this formula. I have that, so this is the first case, okay? This is the case corresponding to this. This is the first case. I have that the length of minus 3 plus w squared is the length of minus 3 squared. Okay, I'd like to try this formula because you have already how to compute its length when we use this picture. Now let's use this formula to see if we get the same thing. Okay, plus the norm of 2w squared minus 2 times the norm of minus 3v times the norm of 2w times, and here you have cosine of 90 degrees, okay, which you know that it's here. So in the end, you have 6 squared plus 6 squared is 36 times 2. So this is the length of A, okay? Let's write this. The length of A. So you have that the length of A is 6 square root of 2. Okay, you can use this formula or you can use this picture to see that you have a square here and you find the diagonal using the Pythagoras theorem, which actually is this one because this cosine theorem reduces to Pythagoras theorem when you have a 90 degrees angle. Okay, so it's the same thing actually. Okay, and you know that the length of B is 1, the length of A is square root of 2. How do you find the angle between A and B? Now you must take a look at this picture. How to find the angle between A and B? So angle between A and B is actually this angle. Let me clean this part. The angle between A and B is the angle between this yellow and this blue, so is this one. Okay. And the angle here is, well, you have 60 here, and here you have if this is a square,
45.
yes, you have 35. Okay, so you have 105 degrees here, but the angle is pi over 3 because this is 3 and 55 is pi over 4. Okay, so this is the angle. Okay, and it's the angle between A and B. I'm going to write in this way. The angle between A and B is pi over 3 plus pi over 4. Then you have all the elements. You know the length of B, you know and you know the length of A. So I'm going to apply this formula again. Let's denote it with a red star. Okay, so apply this formula. We get that the norm of the sum squared is the norm of A squared, which is 36 times 2, plus the norm of B squared, which is 1, minus 2 times 6 squared, 2 times 1, because I have to multiply this part, times cosine, and so we write this way, pi over 3 plus pi over 4. Okay, so that cosine of A plus B means actually cosine of A cosine of B minus sine of A sine of B. Okay, so you have to make the computations here to see the value of each cosine and sine, and in the end you get this sum squared. So you get that u
I have a
minus,
question.
please.
Is it shouldn't be pi minus that pi over 3 plus pi over 4? It's just pi over 3 plus pi over 4?
Where? Here?
Yes.
Do you mean that the angle is not this one, or what is your question?
If in the formula is cos of pi minus alpha, and alpha is not pi over 3 plus pi over 4.
So let's take. No, alpha is this one. So the formula has this one, has this form, right? So the
Yes.
formula means that this one squared is this one squared plus this one squared plus 2 times not A times B times from here, right?
Oh, okay. So is it plus? Okay, okay.
Okay, it's fine. And you have cosine of alpha, where alpha is the angle between A and B. So I didn't use this picture. I have found actually alpha from here because I know that this has 60, this has 45. So I know that alpha, which appears here, this alpha, is pi over 3 plus pi over 4. So I have used this one. Okay, so I have written minus, right? Okay, this was the mistake because I have written minus. Yes, indeed, it was a plus. I wanted first to apply this one, then I have changed my mind, and I thought that it was better to write in this way, and I forgot to put here a plus. Indeed, I have a plus here. Okay, so I have this expression, but it goes minus here because I have those A plus B, which is this. Okay, so I replace this sum, and in the end, this sum, and I find the square of that something. Okay, so this is the first case. And now let's take a look at the second case. So let's see what we should make this drawing. So the second case is following. We have U, which has the length. So it has the length 1. This is U. We know also that just a second. The angle between U and V is 30. So let's say that V is here. But I'm going to draw it this way. Okay, V is here. And this angle is 30. Okay. And that I know that the angle between U and W is pi over 3, which is 60. Okay, so I will write W here. I will write W here. This has 30. This has 30. Okay. Okay, and at 60, and this is double. Okay, so this has 60, this entire is 60. This is W, so it's there, this is 30 and this is 30, okay? Each of them has 30 degrees, and this is 1, this is the length 2, and this is the length 3. And I want to see how the vector u minus 3v plus 2w looks like. Okay, what we should do in this case is to make that picture to see how we can compute this norm, or can we apply the formula directly? Well, u minus 3v will be the sum of this one. Okay, so x is minus 3. I want to draw again the sum of u and minus 3v because I'm going to use this formula. To find the length of the sum between u and minus 3v. And I have the following. The norm of u minus 3v squared will be, and you tell me, this will be how do I find this norm? Here. Sorry, plus, and now I have to minus. Sorry, I was in a hurry to find the value and I have written the wrong sign. So please modify here. Well, how do I find the length of this sum?
Using the same formula with the parallelogram.
It's parallelogram here. Okay, and the angle between u and minus 3v is this one this time, and we want to find this alpha. Okay, so this is alpha in our case. This is alpha. And the value of this alpha is
I minus the angle between W and Y.
pi over 6. Okay, this is the value of the angle between u and minus 3v. Okay, so alpha is this angle. And I have here the u squared plus the norm of minus 3v, but it's the same with the norm of 3v because I have the norm. Okay, plus I'm going to use this formula directly, plus 2 times the norm of u times the norm of minus 3v times cosine of this angle, which is pi minus pi over 6. Okay, and I have that this is 1, this is 6 squared. Okay, 37, or yeah, this is 6. This is 6 plus, okay, I'm trying 36, this was 37, plus times the norm of u, which is 1, this is 6, and this cosine is,
Minus 1.
minus cosine of pi over 6, because this is cosine of pi, cosine of this one, and cosine of pi is minus 1, plus sine of pi, sine of this one, and sine of pi is 0. So this is minus cosine of pi over 6. Okay, and you get here 37 plus 12 times minus cosine of 30 degrees is
1 over 2. Oh, no. Square root of 3 over 2.
it's times pi over is 1 over 2. So this is 37 minus 6 times square root of 3. Okay, this is the value of the length. Is it okay or not? Okay.
It's good because it's not negative.
No, I think that this was 6. Okay. This was good. This was good. Okay. Okay. So the value of the first one. And now let's see the norm phi 1 is 3 plus 2. Okay. How do we find it? How do we find this norm squared? Well, let's see how u minus 3v looks like better. It's a better idea to see how this sum looks like. So this is u, and this angle, this one. Wait, oh. Okay, so this is u minus 3v. Okay, this is u minus 3v. And you have this w, which must be multiplied by 2. Okay, let's suppose that w is smaller because I don't have enough space. Okay, let's suppose that w was this one. And let's suppose that c 2. Okay. What we should
We can use the same method with the parallelogram. No?
Yes, but what we should find first in order to find this norm?
The angle between them, the one
Yes.
above the 2w.
Yes, this is the idea. We have to find the angle between 2w and u minus 3v. Okay, so this is minus 3v. This is w. How do we find this? How do we find this?
We can use the cosinus theorem.
Okay, so you're suggesting that you know this length, which is 1, right? Because this is
Yes.
the length of u. Also, you know the length of this,
Yes, it's
which
minus 3v.
is minus 3v, which is 6 actually. Okay.
Yes.
And you know the length of
U minus 3v.
minus 3v, yes. And you use the cosine theorem to find the angle between u and u minus 3v. Okay, this will be the first step. And then you add this angle with the angle between u and 2W, which is 60 degrees.
Yes.
Yes, because you know that this one has 60 degrees. Okay, so step 1 implies applying the cosine theorem. So we have the triangle with u and minus 3v and the sum. And you know that if you want to find this length of the angle, this measure of the angle, you have to start with this. Okay, so you have that 6 squared. Okay, it's 1 squared plus this 1 squared, which is 37 minus 6 square root of 3. Okay, this is the length squared. Minus 2 times 1 times this length. Okay, so you have here actually a square of 37 minus 6 square root of 3 times, and you'll have here the cosine of, let's say, beta, where beta is this angle between u and this. Okay, and from here you will find cosine of beta, and after you find the cosine of beta from here, you should find the angle beta. You should find beta. So the angle between 2w and u minus 3v, this angle, will be actually beta that you have found from here, plus pi over 3, which is 60 degrees from here. Okay, and using this angle, you will apply again that formula star, which is the length of the sum, and you know the length of this one, you know the length of 2w, which is 6. You know this one, you have to find the length of the sum. If you think that it's easier, actually you can start with 2w minus 3v here to see the length of this sum, and then you take u plus this one, but in the end you will get the same result. So actually it doesn't matter the order. Here you may start this one or with this one, it doesn't matter because in the end you will have the same result. Okay, but this is the idea. Actually, you know this formula from the high school, but now I have tried to deduce it again. So you know that the length of a sum of two vectors which have the common origin is this one. And applying this formula twice in each case, you get the length of the sum. But in the you have to take these two cases because if you choose the first case, you won't have the complete solution. Okay, you have here two drawings. You have to make both of them and to discuss in each case the angle between the vectors, because you see we have different results because the angles are different. Okay, it took me a little longer because I wanted to write all the formulas to deduce, but if you make a fast drawing, you will see how the angles look like. And if you apply twice this formula in each case, you will see that you get a nice result. I don't know if the cosine is nice here. I have to make the computations. I haven't made them. But I hope that it will be a nice cosine. Okay, do you have questions here?
So for this exercise, we get this norm we have to compute like in two. We will get two values for this, or
Your question is if these two cases you get different values.
yes, because we have two cases, no, and
Yes.
or
You have different values because the angles are different.
okay.
So in each case, you have different angles, and you see that the angle is important because it gives you a different value here. So yes, you have to take the two cases, but of course the first one was the easiest case because you had 9 degrees and you have a diagonal in a square and you get a very, very simple angle here, and you can compute very easily this cosine.
Yeah, but this exercise, if you don't make the representation, you can make it very easy. No.
Can you please mai spune o dată, că înțelegi?
If you don't make the representation, the graphic representation, it's not easy to solve it. No.
What actually if you don't know the angle between some values, you cannot find the norm of the sum. So the angle is important. If we don't know the angle, how we can find the sum? I think that it's very important in this case to have an idea of how you solve it. Because if we do not represent the vectors on the paper, we have to represent them in our minds to get the idea about the angle. So it's important to make here a drawing of U, V, and W. Other questions we have? Okay, you have some green screens. I need what questions do you have? Sorry. Okay, share again my screen just a second. What other questions do you
How we can find the conic if the problem only gives us some points in the plane?
How do you find the conic if the problem gives you just some points?
Yes, I have a problem in front here. Find the conic whose graph pass through the points and set some points.
Okay, just a second. Just a second. And put again. What? I close the word. I need to put- I think. Okay. Just a second. Can you please how do you find a conic
if they are given only some points in the plane. Let's say I have this exercise. said to find the conic whose graph passes through the points A01, B minus 0, minus 1, 0, C0 minus 1, D1, 0.
Minus 1, 0, C minus 1, 0.
Yes, it's minus 1, 0, B, and 0 minus 1, C.
Minus 1, and
D is 1, 0.
well, that, but one have something like this in the final exam. Take 1, okay, this is A. Then you have minus 1 and 0. And 0 minus 1, and 1 and 0. So this is A. This is B. This is A. This is D. Well, we have to take each type of cone. Let's say that we talk about arrays. If you have values, you have the reduced equation, which looks in this way. Okay, let's suppose that the center is 0, 0, because see that all these points are the distance one from the 0. Well, in this case, actually, you will, when you take the remaining CMT, your this will be you have 1 and 1 and 1. You have the same distance from each point to the origin.
It's a circle.
Exactly. It's a particular Alex. It's a circle. It's where each is big. Okay. And this is denoted by R, which is called the radius of the circle. So our equation is x squared plus y squared equals r squared. And you have to find r. Okay, so let's say that a of 0 and 1 is here. So it's 0 squared plus 1 squared is r squared. R is positive because R is the length of the radius, and R is 1. Okay, so in this case, the topic is the first with center 0, 0, and radius 1. Then, can you construct a parabola having this?
No, it cannot be a parabola.
Because the reduced equation of parabola is the following: is y equals 2b times x squared for alpha, let's say, and I stop with to half, or let's write this way, and let's split it over x equals 2b times 1 squared. Okay, this is the classical parabola in the high school. This one is for p positive, this one is for p negative, and this is a different parabola. This is inverted parabola. This is for p positive. Okay, this one for p positive, and this one is for p negative. You can construct the parabola if you have the points A, B, D, let's say, or B, C, and D, but just these 3 points. Okay, you can have a parabola such that it contains all these points. You have the distance from your equal to 1. Okay, you cannot construct a parabola this way if condition that A, B, C, and to be on the graph of each parabola, this one or this one. It doesn't matter. You will see that your equation gives you this step. So you would have a solution for these conditions. And if you have hyperbola, the equation of hyperbola is 1 x squared over a squared minus 1 squared over b squared is 1. Or inverse, we step you that minus x squared over a squared plus 4 squared over b squared is 1. And now we have to see if we can construct such hyperbola. What is the reduced equation of this one gives you this root, this for the first case, and this reduced equation gives you this root. But what if here we don't have a reduced equation? Would you draw hyperbola which looks in, let's say, something like this, something like this, and like this. Could you construct such parabola? It's a data parabola actually.
We cannot draw such a parabola because it passing through 2 points and it's not possible.
Also, not a parabola. Sorry, I actually parabolas here. Yeah. Can you construct a parabola to look this way? It's like two parabolas. But actually parabolas. Can you construct something like this? A rotating hyperbola. So the only hyperbola associated with this equation is this one. The hyperbola associated with this equation is this one. But if you find a hyperbola which is rotated, so it will be this way, and it will contain A, B, C, and D. Can you find that hyperbola? Well, the answer is the following. Actually, we have to take the general equation of code, which is a1 x squared plus 2a1 2xy plus a2 2y squared plus 2a1 0x plus 2a2 0y plus a0 0. We have to put this condition to equal to 0. And we have to replace A, B, C, and D in this equation to see if we can obtain these coefficients. But we must pay attention to the fact that a1 squared plus a1 squared plus a2 squared must be different from 0. So most of them are real, and the coefficients, all of them are real. Okay, if you place a equation, if you place a in this equation, you get 0, 0 is 1, a to 2 plus 2 to 0 plus a 0, 0 is 0. Okay, and so on. And from this system, you can get a solution. You will take square plus x squared plus y squared is 1. Because this variable verifies the conditions. Okay, so you see that we can get the okay? But you have another solution except of the circle. We obtain a hyperbola, a rotated hyperbola, or not, because the parabola you cannot obtain from here. But I need to solve this system and find if we get another solution except this one. This is the general idea of solving this problem. But I wanted to first the point to discuss about what type of conics could you draw here. The question is, can I draw a conic? But don't have something like this in the final exam. Okay, what question do you have? What kind of questions? No, have questions.
Yes, I get it. I thought it was harder. That's why I asked.
No, you take each the generate code and to see who can find a conic of each type. Okay, you can see that you have a circle, you don't have a parabola, but parabola they have or not. You must check if you find the coefficients such that you get a form of a conic. Okay, so you have to find if you can see the coefficients such that A, B, C, and D respect this condition. Because it's clear that you cannot have here canonical hyperbola, because a canonical or reduced hyperbola looks in this way or in this way. So your points won't verify this graph or this graph, but you have to see if you can rotate this hyperbola to get something which passes through C. So you have to check this equation with a rotation here. So you don't have questions? Okay, then thank you very much for attention. This was our last meeting on rows. And thank you very much for participating in this project. It was a pleasure for me to teach these lessons for you. And I wish you good luck with your exams. But first, don't leave. I have to download the attendance list and to check the attendance because this is the rule that we have to follow. Just a second. see. Anna,
I'm here.
thank you. Popescu,
I'm here.
thank you. Jana,
Here.
okay, perfect. Corina,
I'm here.
okay. Radu Antonio,
I'm here.
okay. Andreea Nedelcu,
Here.
perfect. Mohamed,
Present.
okay. Octavian,
I'm here.
okay.
Here.
Okay. Thank you very much again. Have a nice day and good luck with your exams.
Thank you. See you in session.
you.
Goodbye.
Okay, goodbye.
See you.
Okay, goodbye. Thank you. Have a nice day.
Bye.
Have a nice day. Goodbye.